Perfect. Awesome.
Welcome, welcome, welcome everyone to Live from NCCE. This is another exciting edition because we have with us Carrie Morrison, who is the District and School Growth Manager at Code.org. She builds partnerships in schools, districts, and communities, and she got her master's degree in educational leadership from the University of Montana. Way to go. We are super excited, Carrie, because we know as educators that coding is so important because it's going to be part of our students' future. So that's why it's got to be in the classrooms so they can use it in their careers. So please, let's take a deep dive and tell us all about it.
Awesome. Thank you so much, Tammy. I appreciate it. I'm so excited to be here with you all today. Again, this is Coding for Classrooms and Careers. So I'll be talking a bit today about both what coding looks like in the classroom, specifically what Code.org has to offer educators and students. And then we'll kind of transition to the second part of this into what does this look like for students in their career paths. So let's go ahead and get started. So again, my name is Carrie Morrison. You kind of already got the introduction. I am a district and school growth manager with Code.org. So essentially what that means is I help schools and districts across 15 states in the Western United States to adopt our curriculum, join our programs, take advantage of our fantastic resources. I connect them with our regional partner network across those states, and our regional partners specifically act as the folks who ensure that educators are getting opportunities to take part in our in-person and virtual professional learning opportunities. I do have my email right here, and I've got LinkedIn listed right there as well. But if you want me, I can list that again at the end too, so that you have ample opportunity to reach out to me. So just a little bit about Code.org. For those of you who aren't terribly familiar with us, our mission is that Code.org is a nonprofit. We're dedicated to expanding access to computer science in schools and increasing participation by young women and students from underrepresented groups. And our vision is that every student in every school has the opportunity to learn computer science. That's really our North Star. That's our bread and butter. That is why we're here. That's what we do. Access to me is very close to my heart. I am here in Idaho, so I work in a state with a lot of very rural areas. I work across states that also have a lot of very rural areas too. So access to me is always at the forefront of my mind when I'm talking to schools and districts. So I want to talk real quickly about what computer science is, because there really is no definitive universal definition. So I like this one. It's pretty straightforward. Computer science, or CS, as you'll see throughout this presentation, we shorten it to CS quite a bit, is the study of computers and computing systems, including their design, use, and impact on society. So it's all of those things. It's not just how do we design these things, how do we use them, but it's also, we talk about in our curriculum, in our program, what is the impact? We're constantly talking about what's the significance, what is the impact of this, which I really love. And then what is artificial intelligence? This is popping up all over the place. It is an issue that is definitely on the minds of a lot of educators I talk to, a lot of administrators I talk to in particular. How do we do this AI thing? What is it? And here again, artificial intelligence doesn't really have a universally agreed upon definition either, but I picked this one. This is actually from IBM's site. Artificial intelligence is technology that enables computers and machines to simulate human learning, comprehension, problem solving, decision making, creativity, and autonomy. And I emphasize the word simulate here because it is so very important to remember that the building blocks of artificial intelligence is coding. It is programming it to do what you want it to do. And we'll talk a little bit more about that as we go through this presentation. So I want to bring your attention real quick to kind of that second part of our mission, where we talk about engaging young women and underrepresented groups in computer science. And this is so important to our work. And we have a lot of focus on it at Code.org. So around 45% of students that are using Code.org programs are female or gender expansive students, which is great. That's pretty close to even. And then right down the middle, 50% are students from underrepresented racial and ethnic groups that are using our programs as well, which is good. We want to see those numbers continue to improve. We want to make sure that there is representation of a lot of diverse viewpoints and perspectives as students are working through a lot of their projects and activities that they're doing. So let's talk a little bit about how to get started with our platform, how to get started with coding in general, because a lot of people don't really know how do I do this thing if I've never done it before in my classroom. And I would say the easiest way, probably the easiest entry point into using code.org is getting started with Hour of Code. A lot of people at this point are familiar with Hour of Code. If you don't know what it is, it's a global movement reaching millions of students across 180 countries. It's always really cool to see the data that we get back after Hour of Code Week, where we get to see all the different countries participating. It's really neat. Anyone, anywhere can organize an Hour of Code event or try out any one of the 100 hour-long tutorials that we have in over 45 languages. I have the link listed right there, and I'll make sure that it's shared with you. And I have a couple images up here. Dance Party is always a really popular one, especially with the younger students. They enjoy it. We released AI for Oceans last year. That's a new one that focuses on how does AI work in an ocean environment when we're talking about how to remove plastic pollution from the oceans, and why is it important that AI is accurate in identifying what is the marine life and what is the trash that we need to remove from the water. So making those connections for students, making sure that they're thinking through those things. And understanding that coding is not this standalone thing. That's not the end goal. It's a means to the end. The end is always figuring out how do we solve a problem using technology. And here's the thing about Hour of Code. You do not have to wait until Computer Science Education Week, which is the first week of December. A lot of people do, and that's totally fine. But you can do Hour of Code with your classrooms at any point in time. And it is very accessible to students and teachers that have never done anything with code before. Now, beyond Hour of Code, what we have is some free, high-quality, open-source curriculum for you to take advantage of. I can't emphasize enough that this is free curriculum, all of it. Anybody at any point in time can create an account and get onto our platform and start using the curriculum whenever they choose. We do recommend that teachers, I highly recommend that teachers go through one of our professional learning opportunities to be able to use our platform as well as they possibly can and take advantage of all of the features that we offer and understand what all is available to them. But with that said, so I'm going to kind of talk through what some of our options are. So Computer Science Fundamentals is our program that we offer, our curriculum that we offer for K through 5 students. So they're courses that are broken up from A through F, so A being for kindergartners, B being for first graders, and so on and so forth. And this is really, I mean, it is the fundamentals of computer science. So we're talking about loops and functions and sequences and conditionals, and you can kind of get an idea of what that looks like with this graphic right here. That sort of shows you these are the building blocks, and then the students figure out progressively how to put those building blocks together to create lines of code. And that's exactly what it looks like. What's really great about this curriculum is that it's very collaborative in nature. Students are typically working in groups or pairs. They're working together a lot of times. So it's not this students are siloed and they're on their computers or their iPads or Google Chromebooks or whatever, and they're not talking to each other. No, it's very collaborative in nature. We want students to see how to work as a team in order to do this, because the reality is in jobs, they're going to have to work as a team. And a lot of times they're going to have to work across teams to create whatever it is they're creating. So this is kind of the beginning of all of that. That's the foundation of all of that. Next, we have CS Discovery. So this is more geared toward middle school students, but it is still introductory in nature. So even if students haven't taken CS Discoveries, or rather CS Fundamentals in elementary school, if they're just diving into coding and they're getting into it at the middle school level, that's totally fine. This is designed to be introductory as well too. But you're getting more into topics like AI, web design, games and animations. Students are getting a little bit more sophisticated as they move through this in order to understand how this is applicable to all these different things that they can do. CS Discoveries is pretty darn flexible. So we've designed it so that it can be broken down into like month-long lessons. It can be taught quarterly or semester-long lessons as well. We recognize that teachers are always kind of trying to do the best they can with what little time they have. So our teaching and learning team and our curriculum developers have done an outstanding job of trying to make all of this as flexible as they possibly can for folks as they go through it. CS Principles is, it can be taught as either an introductory course or an AP course, depending on what the teacher wants, where the students are at. It's designed for grades 9 through 12. And it starts to get more in depth into those topics like programming, data, art and design. There is more games and animations and things like that. But students are typically getting a little bit more sophisticated at that point with the things that they're doing with coding. And then finally, there's AP CSA. So that is strictly an AP course, and it does invite students in grades 9 through 12. Typically, those students by that point have had several classes where they've been exposed to coding and they kind of know what it is and the concepts of it, because they're starting to learn and program using Java. So that's our most advanced course. And if students want to take the APCS exam, they can definitely do that. We always encourage teachers who are teaching APCSA to have their students take the exam when and where they can. So I kind of want to introduce you to some of our new curriculum that we've just recently released to give you sort of a snapshot into some exciting things that we're doing at code.org. So one of the new programs that we have is elementary game design. So we haven't previously had any game design for elementary students. It was all at the middle school level and up. So this is new, it's fun, it's developed specifically to appeal to girls. It introduces elementary level students, typically about grades 3 on to about 6, to basic computer science concepts and behaviors, variables, events, conditional statements in our Sprite Lab. The cool thing about this is the lesson culminates in a game jam, and it does teach those CSTA data standards. Next is Maker with Microbit. So we work with a lot of schools and districts across the country that do a lot with Microbit. It's very popular these days. A lot of districts out there have grant money that they get or they use to be able to get the Microbit physical computing, those components. And so we've actually designed a program specifically for those younger students to be able to take advantage of. We've had Microbit programs for the older students. Now we're starting to get these programs for the younger students as well too, because they have the materials and we make it easy enough for them to be able to start getting introduced to them. So this combines foundational coding with hands-on computing projects. For those kids that are really those kinesthetic learners, this is great for them. These scaffolded lessons lead to a project, which is great. We're always being asked for more project-based lessons and learning opportunities on the Microbit platform. And it is designed to encourage teamwork, collaboration, those interpersonal skills, and engaged learning, which is really great for students that are younger that need to be honing those skills as they're learning computer science. And we also, for the younger students, have how AI makes decisions. Like I said before, AI is at the forefront of a lot of people's minds right now. And so we want to make sure that we're not waiting until kids are older necessarily to start talking about AI. We want to make sure that they're starting to talk about it now, that they understand what it is, and they're able to start at least getting introduced to the concept of AI. So this is how AI makes decisions. Students practice making their own predictions and learning about data categorization and sorting. They learn how to address bias in data and the need for human interaction. That is so important. And it does culminate in a call to action to share your voice, which is what we call it, using what students have learned. So again, it gives them an opportunity to start expressing how they understand it, how it applies to different situations. So for the older students, we also have some new really exciting curricula to offer. Coding with AI, again, for those older grades, lessons emphasizing AI as a supportive tool for coding. Computer vision, this is a very short 3-week course focusing on the design thinking process and application. We just introduced generative AI for humanities. This is just a 2-lesson course, so it's actually pretty short for grades 8 through 12. a lot of these are designed to be integrated into, say, CS fundamentals or CS discoveries for these older students, CS discoveries or CS principles, which is why we've kind of shortened them down so that they can be integrated right in. Generative AI for Humanities empowers students to use AI for brainstorming, drafting and revisions, verifying research. There's always a lot of concern around students using AI to maybe cheat on their assignments. And what we really want to emphasize is, yes, there's always the opportunity for students to use ChatGPT and other tools like that for that reason. But really, we want to emphasize, here's how you can do it without having ChatGPT write your paper for you. You can use it for brainstorming. You can use it for helping to do revisions and verify your research, verify where you're getting your sources from to make sure that they're sound. So trying to emphasize good usage of AI, good ethical usage of AI. And then Foundations of Computer Science is brand new. It's actually still in its beta stage right now. But we have aligned it with the Reimagining CS Pathways Steering Committee and with 2026 CSTA standards. It is only offered right now at the CS Discoveries level, but we hope to have it expanded over the next year or two. Which brings me to technology creating access points to art and literature. And that is so very important, and it's so very true. We have worked with Ishmael Hope. He is an Indigenous scholar and storyteller, and is also a big proponent of students learning how to use coding. Like I mentioned before, coding is not the end goal. Coding is a way to help students get there. And I want to show you how we have kind of created an opportunity for students to be able to use those creative skills with coding. So we are very excited that we are the Best of STEM 2024 winners in 2 different categories. The first category is Trailblazer Inspiring Computational Thinking, and that is for our music lab. We recently launched that in June of this year, and it is so exciting. It is so fun for students. They get to build their own music with coding. And I had the privilege of being able to go and introduce this and do a demo for students, middle school students in Bellevue this past summer, and just watch, give them a few minutes of introduction. Here's what it is, the basics of it, see what you can do. And it was amazing how much fun they had with it, how fast they picked it up, and how creative they got with a lot of the opportunities and the tools that we were giving them within that program. Our curriculum team, our programmers our product team has done a phenomenal job with Music Lab. So I highly encourage you to check it out. We also got the Best Use of AI Assistant for Teaching and Learning Award for our AI Teaching Assistant. Teachers, listen up. This is an amazing tool that our team has developed. Essentially what it does is it does all the assessing of student work. It saves you a lot of time in accordance with our code.org rubric, but it saves you potentially hours and hours and hours of your time of going back through all of the code that the students have submitted and checking for mistakes. Our AI teaching assistant can do that for you. So this is really kind of revolutionary in terms of freeing you up to be able to spend your time doing more of what you want and need to do rather than grading individual lines of code. So that one's pretty cool too. So that's kind of the what we have going on, barely scratching the surface. I could go on for a very, very long time, but I have a limited amount of time to be able to talk to you today. So I want to kind of transition into the why is this important? And I want to do that first by sharing a quick video with you and talking about how specifically computer science is everywhere and how it's being used in all these different industries.
I think 19th century was about the Industrial Revolution, about electricity, about disrupting the agricultural society and making it more advanced. The 20th century was about physics and engineering to do more things easier in our everyday life, from refrigerators to washing machines.
How convenient.
And the 21st century is definitely the digital age. It's the internet.
Even if you want to become a race car driver or play baseball, or build a house, and all of these things have been turned upside down by software.
The LettuceBot is a robot that can sense its environment. Every single hour, this LettuceBot is seeing 1.5 million plants, and it's taking individual action on those plants. We enable lettuce growers to have higher yields in their field by helping make it cheaper, by helping produce food in a more sustainable way. And that wasn't previously possible without computer science and technology.
I have a really fun job where we build Polyvore, which kind of combines all my favorite things. So programming, as well as fashion and art and design and shopping. Half the products you use these days are software products that you play with on maybe your phone. And so if you want to build something cool, you need to know programming, right? And there's so many things that you can do with computer science. So if you just work backwards from the cool thing that you want to build and figure out what that is, a lot of times computer programming is part of that, right? So you should learn the skill.
It's really exciting right now. The technology that we're developing right now is going to be used by your doctor in the next decade. When you come into the office and you're sick, the doctor is going to be like, all right, spit in this cup. And I will put it into this magic machine, which is a sequencer. And in an hour, I can tell you what you have or what's wrong with you. So if we're looking for a new virus, for example, we'll download a database of all the viruses that are known. And we'll search for, our sequence of interest against a whole database of all viruses. So you still need somebody to analyze the data. The computer is not smart enough yet.
Our software helps people save energy and thereby reduce their carbon emissions. To date, we've saved over 8 terawatt hours, which is the equivalent of about 1.1 million cars on the road.
When you're forecasting the wind, there's so many different parameters that go into it. It would be impossible for a human to sit down and do all those calculations. We need a computer model in order to forecast it.
I write software which scans images, looking for bad images that we know are illegal. I work very closely with organizations like the National Center for Missing Children. I know that the work that we've done has impacted the life of people. And I feel very strongly about it because there's a lot of social problems right now that could really leverage the use of technology. It's a lot about empowering the people who are there helping the world by giving them the tools to be able to do better. That's something that we can do right now, and the tools available are huge.
The merging of art and technology is getting more and more significant now because computers and software are such an integral part of our lives day to day. People are realizing that it can be quite creative to take this medium of computers and create incredible works of art.
In Finding Nemo, when Crush and Squirt and all the friends are flying through the East Australian Current, you're seeing images of water flowing by, you're seeing the colors on the back of the turtle, you're seeing the sides of the fish. All of those things are generated through math and computer programs that we write that we then give to the artists, and they take that to create that final image and tweak it and make it look beautiful and look fun.
The crux of it is really about invention. It's about looking at the world and being dissatisfied with things and questioning everything.
I always felt like if I didn't learn how to program, it would be like not learning how to read. The future would just be closed to me.
If you're in the coding profession, there's so many things that you can do, and you can pretty much pick and choose the course you want to be in.
I think that you can start something in your college dorm room, and you can have a set of people who haven't built a big company before come together and build something that 1 billion people use as part of their daily lives is just crazy to think about, right? It's humbling and it's amazing.
Really, it's about the chance to reinvent things and then see it out there in the world and see people using it and having fun or having a better life because of something that wasn't there before that you put in the world.
So, as you've just seen, computer science it's being integrated more and more and being relied on more and more in so many different industries. And that's why a lot of students and parents agree on computer science. Last we surveyed, 88% of students say CS jobs will be in greater demand in 10 years. 85% of parents say the same thing, and they are absolutely 100% correct. It is going to be more integrated into all these different industries. And you've just seen, again, like barely scratching the surface on what some people are doing and how they're innovating out there and why it's so important to be exposed to some computer science. Also, AI literacy, same thing. 74% of teachers in the United States say AI literacy will be a key skill for future jobs. 60% of teachers globally say the same. And AI it's only going to accelerate in its usage. And like I mentioned before, the building blocks of AI are coding, it is programming, and it is so important for students to know that they have to be aware of things like inherent bias as they're programming for AI, so that AI is the most effective when it's actually out in the world and it's being used in real time. And all of these students and parents and teachers are correct in that it is good to learn the basics of computer science because it does lead to gains. The Brown Center for Education Policy at Brookings Institute found when they did a study that exposure to high school computer science creates economic gains to the tune of 3%, who are likelier to be employed, and 8% more in earnings for those students that have had some exposure to it. What I am really excited about is the exposure leading to disproportionately higher earnings for certain groups. This is really exciting. 10% more for female students, 14% for low socioeconomic status students, and 12% more for Black students who've had some exposure to computer science at the high school level. That's just high school. That's not even students that have had computer science exposure from kindergarten on up. So it's really exciting to think about, if you just have that little bit of background, that little bit of understanding and exposure, that it can make you that much more marketable as you move into your careers. We already kind of saw a little bit about some industries that are using computer science. These are some of the top ones that I found in my research when I looked up what are industries where coding is really emerging, AI is really emerging. Agriculture, like you saw, automotive certainly is relying more heavily on computer science and coding and AI, bookkeeping and tax preparation, chemical engineering, esports, finance, food service. Just about anything you could imagine is, it has more of a demand for coding. I was even talking to somebody recently too, who was saying that they work with students who are transitioning from high school to college. And she was saying, I can't believe it, but more business programs at universities want students with a coding background, or at least some exposure to coding, business schools. So it was interesting to hear, but it makes sense because a lot of those students go into accounting and tax prep and other aspects of business, marketing, things like that, that are relying more heavily on coding and AI. That being said, there is still a gender disparity, especially in computer science, of a lot of the STEM fields out there. About 20% right now of computer science undergraduate degrees in the United States are earned by women. And as somebody who was previously the department manager for a computer science department at a university, that's no surprise. We had one female student in the program where I was at, everybody else was male. So we need more women in this field. We need more of those diverse perspectives. They are critical. Also, 46% of girls are likelier to pursue a CS degree if they take the AP CS exam. So we know that that exposure correlates more to girls feeling more empowered, like they may have a future in computer science. And what I would say is encourage your students. I pulled this quote from Scientific American. I won't read the whole thing, but essentially what it's saying is when girls, especially from a young age, are told, well, this is more a thing for boys. Like I used to hear all the time when I was younger about math. Math is more for boys. Art is more for girls, that kind of thing. It gets into your psyche, and it ultimately is, it's discouraging in the long term for girls that may actually want to explore computer science and want to create with it and innovate with it and have fun with it. And it is what we've seen too when we've talked to girls, especially middle school girls and high school age girls, is I'm more likely to take a computer science class if a friend of mine who's a girl is also taking the class with me. So it's just so important to make sure that as teachers, as educators, we're very conscientious of the language that we use when we're talking to students about computer science, especially female educators too, and saying, like, even if you've never had exposure to coding, like, I can learn this, we can do this, and we can do this together. I talk to people all the time who are just getting into teaching coding, and they say, I'm learning right along with my students. And I tell them, that's fine. That's how it is for a lot of us who don't have that formal computer science background. So I want to invite everybody here today to reach out for free, high quality curriculum and resources, support with your CS education integration plans, professional learning opportunities, and so much more. Please, please, please feel free to reach out to me at carrie.morrison@code.org. I also have linked down here our district program that we have. That's code.org/districts for anybody who is wanting to partner with us and be able to not only use our free resources, but get some support when it comes to integrating computer science across the board and get a little bit of guidance and a little bit of help on how do we do this computer science thing more intentionally and more effectively. Right here, the code.org/careers, you will find all sorts of resources on our CS Journeys page when it comes to career pathways and other things that students and educators may want to check out. Our curriculum catalog is down here as well at studio.code.org/catalog. That has everything on there if you want to see our catalog. And then we also have self-paced professional learning options that we offer, again, completely for free through our website. And you can get started on those at any time. You can stop at any time, pick it up whenever you have additional time to spend on it. But I highly encourage you to spend time on those. And then the QR code over here just takes you to the enrollment form. If you are interested in our district program and becoming a partner with us, that will take you to the enrollment form. But again, if you have any questions, you want to reach out at all, please feel free to do so. I'm more than happy to answer any questions.
That is so incredible. There is absolutely so many resources that you all provide. Everyone is just going nuts. But I have a question that we've been wondering. You have so many resources. What kind of a team do you have? Who puts all of these together? Do you have former teachers? Do you have?
Yes. Yes. So I am so very fortunate to work with some incredibly amazing people. And that is one of my favorite, in all full transparency, that is one of my favorite things about working for code.org is the incredible team of professionals I work with. A lot of them are former educators themselves. So a lot of the folks that are developing our in-house curriculum are former teachers. They have been either teaching, they were teaching code.org for many years before they came on board with us, or they were teaching computer science for a long time and they wanted to do more and focus on curriculum development. And so they came on board with us. But yeah, we have an amazing team of teaching and learning specialists. We have an amazing product team. What's great about those folks is that they want feedback. They so want feedback. And I haven't even touched on everything that we have to offer, but our LMS integration team that we have LMS integration now with Clever, with Canvas, with Schoology, and with Google Classroom, and they want feedback. They're constantly asking, what are people saying about now we've done all this and we have all these resources? So I love how eager everyone at code.org is for feedback. We want to make it better. We really want to make it the best that we can possibly offer.
Of course. What's the best way to send feedback to the team? To email you or?
Yeah, absolutely. You can email me. I'm always glad to kind of be the conduit because a lot of times, even if you have feedback about certain things, we can kind of have a conversation and maybe you learn something new about what we have to offer that you might not have known about before. So yes, I absolutely encourage you to reach out to me.
Outstanding. Well, Carrie, we are so thrilled to have you here with us today. Thank you so much. Everyone, thank you for joining us. And remember, we're back in a month for another Live from NCCE in the beautiful month of October. Carrie, thank you again for your time and talent. And that's this month's episode of Live from NCCE.
Thank you so much.